Hey Probstats kids, this is Dr. Callahan with Week 12 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following questions. Okay, so let's go ahead and get started today. So this is our second day of Euler's circuits and path. And so the one paper that you need to have is this one right here. So if you don't have it just yet, make sure you just kind of follow along with the video. All right, so this is the second day of doing this. The first day I talked to you guys about the differences between Euler's path and Euler's circuit. We talked about vertices and edges, even and odd, and also the countings. So if this sounds really, really confusing to you, then I suggest you need to go back to week 12 Monday and view that video first before you guys start with this one, because it will be a little bit more complicated. And then this is going to be part of your warm-up that has the answers to it. So go ahead and just do a quick little check. Okay, so first thing what I want you guys to do is you are going to do a marble slide on this with Desmos. So what you're going to do is you're going to go to the following. And I'm going to go ahead and assign to the class here. View dashboard. And then what you're going to do is you are simply just going to go to https://student.desmos.com activity builders /student-greeting 606B82EC9DD81 632D44E2A6B, and you're going to go ahead and get there. Okay, so then go ahead and answer the following questions and make sure you guys do that. There are 24 questions here for you to play around with in terms of the path, okay? All right, so if you're done with that, then I'm gonna have you guys go ahead and get started with the notes today, which looks like this. So we're gonna start off right there. All right, so go ahead and read this part right here. All right, so is it possible for us to find the correct path in terms of doing this? So looking at this, is it possible for us to go ahead and cross all of the path and bridges here, get to the other side? Well, let's give it a try. If I decide to go down this path, go down this path, and then go around here, go through this bridge, go down this bridge, and then end up here. The problem is that you are kind of missing this bridge right here. So for this one, it is not possible. Although you can try to draw it with your fingers and see if there's another path that you can do, but from what I can see, it's not going to happen, unfortunately. All right, let's take a look at this one here. If I start right here, is it possible to go through every single doorway? Well, let's try. I'm gonna go down here, here. I'm gonna go through here, here, back in, back out, back in, out, in, and oh, that's what I ended up with. But then I'm missing this piece right here. So with this one, it is also not possible. And you can try the different pathways if you would like. Okay, so now that we've done this, let's see if it's possible for us to maybe draw the Euler's diagram to the path itself, okay? If I assign this part to be A, center to be B, C, and D, let's go ahead and draw the path of this. So I could technically go from path A over to B, C, D. So I'm going to draw the dots right here as well. From A, I can go to B. B, I can go to C. C, I can go to D. D, I can go to A. Oops. A. From A, I can go back to B. And from B, I can go back to C. So then as I'm counting the vertices for this, from this dot here, how many edges do I have? 3. From this vertex, how many edges? 4. From this part, I have 1, 2, 3, 3 edges. D, I really have, actually, no, I'm missing one right here because I forgot to go from here to here, sorry. So I have 3 for D, and that is about it. All right, next part. For the next part, if the graph can't be created without picking up a pencil and without ever retracing any edges, the graph is said to be transversable of some of these transfer as Euler circuit or Euler path. Can you determine which are transversable? Circle the ones that are. Well, let's take a look over here. Here I have 3, 3, 3, and 3 edges. Okay, so these are odd. So then looking at this part right here, remember, in order to become a Euler circuit or a Euler path, it has to be even edges like that, okay, where there is E1, E2, E3, E4. So looking at this, we could certainly try, but let's take a look and see. Go this way, this way, this way, this way. Won't be able to finish it. So maybe try another location. Let's try maybe this way, this way, this way, this way, this way. Still missing it. So for this one, it's just really not possible. Now let's take a look at the next one here. With this one, I have the edges of, let's see, it's 2. This one is 3, 3, 3, 2, 3. So by that means, since I have some evens, that means I could probably have a Euler path or circuit. So let's see, this way, this way, this way, this way, this way, this way, this way. Oh, so close, but that one didn't work. So let's try a different way. Let's try this way, this way, this way, this. Still not possible. So this one, it's not possible as well, unless you can find another one, another way that you can actually make it so you don't have to retrace any of the steps. So what I want you guys to do right now is go ahead and try some of these ones on your own. Pause the video and see if it's possible to make it into a Euler path so you're not retracing any of the edges. Here's my answer. Take a look at it. All right, let's go on to the next part over here. Okay, it says label the degree for each of the vertex, put a circle around the following graph that have a Euler circuit, and list a possible circuit. Briefly explain why a Euler circuit must have all even degree vertices. C, put a square around the following that have a Euler path, and then list all the possible paths. Briefly explain why a Euler path must have 2 odd vertices and the rest even. And just so you guys remember what they are, when I'm talking about like even vertices is like if I have a point here and there's edge 1, edge 2. So that's a vertice 2, and that's even, okay? Odd vertices is like this. So at this vertice, there's 1, 2, 3. So it's an odd vertice. That's what it's talking about. So let's go ahead and take a look at the first one here. This one is a vertice of 2. This one is a 4, 2, 4, 2, 4. So since the vertices here are all even, you know it's going to be a circuit. A circuit just means that you start and end at the same point. So if I start at this red point, let's see how that's going to be possible. I'm going to go from A to B, B to C, C to D, D to E, or whoops, D to E, E to F, F back to D, back to B, and back to E. So the path here is A, B, C, D, E, F, D, B, E, A. Now I want you guys to go ahead and do that for the next 4 questions as well. Pause the video. And here are your answers. All right, so now let's take a look over here. Create a graph of the following map and explain whether it's possible to pass through the door exactly once. So I'm going to go ahead, you can start anywhere you want. So I'm going to go ahead and try to start with room E. So then from the room E, I'm going to go into room C, from C to D. D, I am going to go to A, go back to C goes back to B. Then from B, I'm going to go back to A, and then outside, going back to B, into room A, outside, go back to D, back to E, and then there we go. So I went ahead and went through every single room, and I made it outside. So this one, it's possible. Now, while you're doing this, I want you guys to trace a path. So A, C, D, E, B. So let's go ahead and trace a path with this. So we started off with E. From E, I go to C. C goes to D. From D, I go back to A. A goes to B. B goes then to, A goes to B. B then goes back to A. And then from A, I'm going to go over to D. From D, I'm going to go out to outside. So something similar to this. Now do the same thing for the right side, for the outside. All right, you guys, as always, stay safe and healthy. Here is the answer for the very last one right here. And I'll see you guys next time. Take care.